All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to continue working on my silly Rust practice program. I didn't actually make too much progress with that. I made a little progress off stream. Um, I think it was 2 streams ago when I started doing it, and at that point I did it on stream. And then that day, later that day, I did some research um, on various things. I can't remember at this point what all I was doing research on there. Hold on, let me look at the code again. Oh yeah, yeah. Now I remember. There was a bunch of this stuff that I kind of got, let's say, intrigued by. I think this was called fully qualified name, something along those lines. I was very intrigued by the syntax over here, and so I started doing research on that. I um, I think my interest in it came from probably Collect. I'm not sure. I think it came from Collect. Yeah, I think it came from Collect. So I probably would have been able to call this in a different way. I just want to test this out real quick because initially I was trying to understand how this whole thing was implemented. Because here it mentions one generic parameter, one generic type, but the generic type is not what's being sent in, it's what's being sent out. So this is going to produce a generic type, and that is why we have to give it some sort of type annotation. We have to give the compiler, some idea of what we are expecting to send out. And there is also a trait bound saying that we have to whatever type we are returning, it has to implement from iterator for self item. Self here, I believe, is this thing. Yeah, yeah. So we have to, and this is incredibly complex because if you think about it, self dot item here, the self dot item is I32. It's not mentioned what self dot item is. However, down here you can see self, and self is ranged I32. The I32 is the item of self here. So we have a trait bound saying B is what's going to be returned, and B must implement from iterator I32 for, um, well, yeah, it must implement. B must implement from iterator I32. So I guess a different way of writing this would be, let's try this. Hold on, hold on. So this, it doesn't get consumed, does it? It says self. I think it gets consumed. Oh wait, never mind. It's the range anyways. So how would I go about writing this? Okay, let's say let mute nums O1 or O2, and we are expecting a vec I32, right? Instead of, okay, let's not give the type annotation here. We are expecting a vec I32, and we are expecting to call, we are expecting to call, um, I'm trying to use this thing, this fully qualified name syntax over here. I'm trying to think of a way to do this. So if we say, um, what's the idea here? So down here we are calling so and so dot fly, right? Up here we could do, because I mean here we already have a value, don't we? So how would we reproduce this example? Yeah, I don't want to move on from this until I've figured this out. So here we could do perhaps, let's say, range I32 as from iterator I32, and then we can get a from iter. We get a from iter. We do not get a collect. Yeah, we don't get a collect from it. Now, what does this method take in? The method takes in, oh, okay, in that case, I guess what we would be doing is, hold on, let's erase this whole thing. Um, how we would go about this is we are looking for vec I32 as from iter. I wasn't thinking about this very clearly because what we are expecting here is we're expecting to get an iterator, right? So if we pass in, and how are we specifying the type of what we are passing in? Like let's say 1 to 10. Is that acceptable? I don't know. Oh, I'm missing one bracket. That's apparently acceptable. That's apparently acceptable. What does collect do exactly then? Um, okay, note that we needed the so and so on the left-hand side. Yep. This is because we could collect into, for example, vec so and so instead. All right. Using turbofish. Yep. Okay. All right. I guess what we did here is the equivalent of using the turbofish syntax. Um, yeah, I guess what we did here is the equivalent of using the turbofish syntax. So vec I32 as from iter, and when we do that, then we will be able to access the specific members that are implemented for, or the specific methods that are implemented for that trait on vec I32. And then we are able to pass in range. But then I'm trying to call this, okay, what what exactly creates this collect method? Let's try going to this. We are looking at, okay, where is this implemented exactly? Transfer. Okay, this is in iterator. So this is the example. We have collect and collect. Oh, collect is just calling from iter. Okay, all right. So that answers my question. That clears up my doubt because what we would be what we are doing here, real quick, let's just get rid of all the noise. What we are doing here, um, with the fully qualified name thing, we are basically doing exactly what this would have been doing through the collect method. It's just that the collect method is a lot. Um, it's a more elegant way of, or I don't know if I should say elegant, but it's I don't know what word to use here, what word to describe it. It's just a much more it's a much better looking it's a much better looking way. It's a more easier way as well, to be honest, because it's so much easier to do this, range dot collect and then vec I32. It's also more I want to say understandable because we are saying that, okay, this is a range, and then on this range we are calling the collect method, which then gives us, oh, we are calling the collect method and specifying that we want the return type to be vec i32. um, it is definitely a lot more elegant than this. This is this can be I can see how this can be a little intimidating. This can be a little I'm not sure what word to use there, but I feel like this looks a lot simpler and a lot more friendlier, a lot less intimidating than whatever this is. Right, but I am very interested in learning about how this is working, the fully qualified thing. Also, does this mean, okay, um, so range, let's say range I32 as, I don't think it gives me, yeah, I don't think it gives me the thing. So let's say iterator, this is a trait, and this is a module. No, no, what is this? An iterator over a distribution. Oh, hold on, give me a second. Um, a trait dealing with so and so. Yeah, I guess this is what I'm looking for, right? What is collect implemented in? That's the thing I don't know. Uh, let's do this and this. Um, hold on. Can I see LSP symbols through trouble? Okay, it's not showing it here. Right. How do I go up to the trait? There's a bunch of stuff here. Hold on. Okay. All right. Next, there's the trait. Trait iterator. So I'm trying to, what did I just do? Oh, got my shortcuts mixed up. So then I guess I'm supposed to do this. Like, does that work? It does. Okay, it does. And then we call collect on this. Okay, now collect takes self, but collect returns a generic type. Yes, collect returns a generic type. So we would technically still need the turbofish syntax, or we would need to explicitly tell backup. What are we passing into this? We are passing in a ranged thing. Yeah, yeah. Okay, so we'll pass in a range. Okay, 1 to 10. And then this should throw an error. It's not throwing an error though. Range as I32 dot collect backup. I didn't get that. Okay, hold on. Let mute nums. Wait, send this down. Nums 03 equals so and so. Still no. Oh, wait, there's supposed to be an error. I just disabled the diagnostics. That's why it's not showing an error. Okay. What is it telling us? Cannot find type range in this scope. Trait takes 0 arguments, but 1 generic argument supplied. All right. I'm mixing something up here. Okay, let's try this. Okay. Cannot find range. What am I doing wrong over here? Range, should it be ops? I think it's ops. Yeah, I think range is ops. And then I have to give the type, right? IDX is the type. Okay, how about now? And now it's saying type annotation needed. So we provide the type annotation here, and we say vec I32. And now it's okay. All right, closing this. Now you can see how long this would look if I called collect in this way versus if I'm calling collect in this way. There's a big difference between the two. This is why I wanna explore this so much more. I'm actually a lot more curious about how we are jumping around in this, because it kind of seems to me like there might be a blanket implementation somewhere, some sort of implied implementation. I'm not sure. I think I need to wait. I'm in the docs, right? Uh, where do I have the docs open? Rust iflet, because I don't want to. Oh, string search. Okay. Here, let's look up iterator. In the iterator trait, I spelled iterator wrong. In the iterator trait, am I in the wrong thing? I'm in the wrong thing. I'm in the inquire creates docs. Do the inquire docs lead to... Okay, would this lead me to um yeah, I think it would. Nightly. Okay, great. Awesome. Iterator, spell that wrong. Iterator, that's a trait. That's what I'm looking for. Now, here we have 76 methods. I am looking for the collect method specifically, but I also want to see if it mentions... Okay, it mentions implementers here. Impl so and so for a bunch of these things. Impl for I think I'm looking for from iter. Actually, no, I'm not looking for from iter, because that would be... Yeah, no. I'm not looking for that. I'm looking for... I actually don't know what I'm looking for. Iterator for so and so, so and so. Yeah, I don't think I'm gonna find what I'm looking for here, because I'm not entirely sure what it is that I'm looking for. Let's look at the collect method and see if that gives us anything. Collect takes ownership of an iterator and produces whichever collection type you request. The iterator itself carries no knowledge of the eventual container. The target collection is chosen entirely by the type you ask collect to return. So that's why we have to specify the type. That's why we have to give the type annotation. This makes collect one of the more powerful methods in the standard library, and it shows up in a wide variety of contexts. The most basic pattern in which collect is used is to turn one collection into another. You take a collection, call iter on it, do a bunch of transformations, and then collect at the end. Collect can also create instances of types that are not typical collections. For example, a string can be built from chars, and an iterator of result so-and-so items can be collected into so-and-so. Because collect is so general, it can cause problems with type inference. As such, collect is one of the few times you'll see the syntax affectionately known as the turbofish syntax. This helps the inference algorithm understand specifically which collection you're trying to collect into. Give me a second. I just realized that I didn't open up my chat. So I'm just going to do that real quick. Also, let me see how we're doing on frames. We seem to be doing well on frames. Okay, let me open up my stream. Okay, all right. Now, um, yeah, there's a lot to look at here. I feel like I need to like expand on this, explore this further. I'm not sure what dots I'm trying to connect, but I know I'm trying to connect some dots to get an understanding of what's going on here. Because I know that, oh, give me a second. Okay. All right. I think I might just, you know what? Maybe I'll do this exploration off stream. I'll probably make note of this this study that I'm trying to do because I know that I'm looking to understand. Okay, collect. So collect is implemented on from, no, collect is implemented on iterator. Internally, collect just calls from iterator. Sorry, internally collect just calls from iter, which is a method implemented on the from iterator trait. And the only reason why this works is because there's a trait bound for collect saying that whatever we are passing in, there has to be an implementation of from iterator that type for that so and so. I'm not sure how to say that because there's two generic types here. Basically, if we are trying to get a vec i32 out of collect, so B is supposed to be vec i32, um, vec is going to be our B, and what we are saying is that there has to be an implementation of i32. There has to be an implementation of from iterator i32 for vec in order for vec i32 um, to be what's the word, to be a qualified, to be a relevant, to be in order for us to be able to pass this. I'm not getting the right word, like something that's allowed. In order for that type to be allowed to be passed in, this trait bound has to be satisfied, right? And then there's a trait bound for self itself. Um, so here we are trying to here collect internally calls from iterator from iter, and does that in a way make this a blanket implementation? I need to ask Gemini about this. Hold on. Hey, so if I'm able, hey, so if I'm, hey, so in Rust, if I'm able to do so and so, so range 1 to 10 dot collect, and then turbofish, we do this and pass vec i32. And if collect is just calling from underscore iter internally, does that mean there's some sort of blanket implementation here? I'm 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 not sure like what exactly I'm not sure how exactly to look at this, and that's why I want to know if oh, okay. So Gemini says spot on. You've got great intuition for how Rust's trait system connects under the hood. Yes, there is absolutely a blanket implementation at play here. When you call collect vec i32, you are invoking a method from the iterator trait. The reason this works seamlessly is due to a blanket implementation provided by the standard library for the from iterator trait. Okay, okay, hold on. So we are gonna do this. Okay, and we're gonna search for from iterator. Oh God, this is a long list. Okay. From iterator. Okay, there's a trait method. This is the trait itself. All right. Conversion from an iterator by implementing. Wait, hold on. They might mention here. Okay, what's under implementers? Okay. Do I see? Actually, that would be for a trait, right? What we are seeing here is um, from iterator being implemented for types. Maybe the blanket implementation is at the bottom. No, but I do see vec dq, so there might be vec here as well. There is collects an iterator into so and so, commonly called via. Okay, impl from iterator for so and so. This this doesn't just seem like a blanket implementation. This seems like that reflexivity logic. This basically allows you to pass in this type for, in situations where I'm not sure how to say that, but this seems like the reflexivity thing. It does not mention. Okay, Gemini said the blanket implementation in the Rust standard library core iter, you will find a blanket implementation that looks essentially like this. Okay, so they're saying it should be in here. Let's see if we can find this. Into iterator. Okay, impulse so-and-so for I. This allows iterator to automatically become an into iterator. But more specific to your question about collect and from iter, the iterator.collect method itself is defined like so. So fn so and so so and so. Okay, what this means for vec, because collect just forwards the call to from iterator from iter, it relies on the target collection implement on it my god. It relies on the target collection implementing from iterator. Okay, all right. The standard library provides this implementation for vec. Oh yeah, you know what? We actually did not look at the logic for from iter. So let's go take a look at that. And yeah, it does mention here that the trait bound for I is that it has to implement into iterator. And in this case, range apparently does. Okay, okay. So this is what Gemini is telling me. This is what Gemini is showing me. Also, this is interesting because it's using that fully qualified name thing. I don't remember exactly what it's called, but it's using that self as so and so from iter. So wait, there's a second from iter, but that's for this. Okay, what is into iter here? It's a type that is iterator item self item. Okay, I didn't fully get that. Um, it's I dot. Okay, into iter is supposed to be the iterator itself. Into iter is supposed to be the iterator itself. So if I go to the definition here, which kind of iterator are we turning this into? Okay, all right. Okay, you know what? I'm gonna explore this. Actually, I think, dude, I think for the most part, I'm done exploring this. Um, I feel like I want to explore this some more, but I'm not really sure what exactly I'm trying to understand. Which tells me that I think I'm ready to move on from this and do um my exercises or my exercise. I actually forgot that I was doing this all within the exercise code. Let's get rid of all this. There was one more thing here. There was something to do with, was it RNG? No, we were passing. Oh, um, when we have RNG, then there's something implemented for this. I forgot what it's called. Yeah, yeah, there was something implemented for this. Well, I don't think it was collect. Was it collect? I don't think it was collect. Let's hold on. Let's say RNG. Is RNG the type? RNG is showing up as a trait here, but I'm trying to do, okay, let's do rand RNG. It's still not working. That's a trait. I'm not trying to do that. Let's look at the random generator example. Sorry, the random crate example. Dude, I'm so hungry. I'm waiting for my food to be ready, and in the meantime, I wanted to stream, so I'm streaming. Probably only gonna stream for an hour today because I became a little late to start the stream because I was doing other stuff. Give me a second. I'm just looking up the Rand crate on another machine. Oh, it's choose. So what we do is um we do we create an iterator. Here we've created nums. Let's delete all of this. Are we getting any errors? No. Okay, so we then here we are able to call choose, and the reason we're able to call it is because apparently that is implemented. And in here we have to pass in our RNG thing, and then we get our value. The value here is what? Self.output. So then I guess I have to unwrap it as well. Yeah, I think, wait, what is it? It's an option. Yeah, yeah. So if I unwrap it, I'll get a sum out of it. So let's say let so and so RNG underscore num or one. So that needs to be unwrapped. So that is our random number. And each time I would just need to call this method and unwrap it, and I'll get a new random number out of that. So the next thing I need to do here is I forgot what this logic was supposed to look like. Okay, feeding it makes it bored. Ignoring it makes it spicy. Every time the loop runs, what all are the actions? Have the actions been like described somewhere? I can't remember. Uh, okay, have I described the actions somewhere? Action. Feed, pet, scold, ignore. All right. Okay. Something we could do here is if we are ignoring, I mean, I was gonna have like an external state, not external, an internal state being maintained, which keeps track of like, the number of turns and um, how long something has been going on, like how long I've been ignoring the pet. But I don't wanna overcomplicate this because otherwise I'm not gonna finish the exercise. I'm gonna really overcomplicate it and just keep working on this and not get any other stuff done. So I think what I want to do is make it so when thing, a certain action happens here, the mood will switch to one of these, and then a random sentence will be chosen from this array. So what I've done here, actually not one array, it's a hash map, it's a dictionary, and in the dictionary I have 4 keys. I've just given them integers 0, 1, 2, 3, and they correspond to basically this. So that's why I implemented try from on action and try from on mood as well, just in case I need to, you know, use try from on them. And it's basically supposed to return the mood itself. So it could return, well, in this case, it's supposed to return the action for any given integer. It's supposed to return what the action is. Though, I mean, if I know the action, if, okay, there's try from, is there a try to or an into? I think this is where I could set up an into, right? Oh, dude, this is where I could set up an into. I could set up a blanket implementation here. I wanna try that. Hold on, dude. I wanna try that. So I'm trying to get an action out of it. What would that look like here? Because once I implement from, then that'll imply an into implementation. So let's do from I32 for action. And here we implement our from thing. And this returns, we pretty much do this, right? Okay, this can return, okay, this can fail. This can fail. If there's a from thing, yeah, how do we handle if this fails? Because I wanted to return self here, but it seems like I would need to return self, or no, not return result. I would need to return a result which would be self or error. But then error is not implemented here. So that would become a bit of an issue. Oh, I guess that's where try from comes in, right? So if I did try from, hold on, let's return ignore for now. So this implementation is done. Conflicting implementation. Wait, is this causing a problem? Oh, that's crazy. Wait, this is causing a problem. Conflicting implementation of trait try from for action, conflicting implementation and create so and so. Oh, wait, does try from also imply into? Let me look that up. Try, okay, try from. This is the trait, generic implementation. There it is. Wait, there it isn't. No, back up. I read that too quickly. No, it says try from implies try into. It doesn't say it implies into. So why is this an issue? Um, I'm not sure. Hold on. I'm going to open up a new conversation again. Hey, in Rust, why am I not able to um, implement try from and from on a type without getting an error relating to into? It's a classic Rust rite of passage to trip over this exact error. The short answer is Rust already implemented try from for you via blanket implementation in the standard library. Because you are trying to implement it again, the compiler gets confused and throws an error that mentions into or try into. Here's exactly. Is that true? Wait. No, I'm not getting an error over here. Yeah, I'm not getting an error here. I only seem to be getting it here. This is saying impl so and so for t where convert into, it specifically mentions into here. Okay, wait. Let's continue reading. Rust's standard library includes a blanket implementation that automatically provides try from for any type that already implements from. How does it know what the correct logic is supposed to be then? So like if I did this, it's implemented, right? But then action, try from, try into is also implemented. Is that because into has been implemented and so based on that logic, try into is automatically implemented? That is insane. Hold on. We need to come here, try into. Wait, that's just a trait. Where can I see a blanket implementation of this? I need to trace this back. Okay, try from for t where t is from. If you have from, you automatically get try from for free. Let's see. So let's do try from. Come here. Okay, generic. Where does it mention that I get this for free? Is try from being, this is the trait. Uh this is the trait. So how would I be able to see where this blanket implementation is? Let's do from and go into that. Okay, and in here, let's see if we get, okay, an attempted conversion that consumes so-and-so. Library authors should usually not directly implement this trait, but should prefer implementing the try from trait, which offers greater flexibility and provides an equivalent try into implementation for free, thanks to a blanket implementation in the standard library. For more information on this, see the documentation for into. Let's do that. Let's do that. There's try into, and from here we're going to go into into. So there's try into, and into has to be mentioned somewhere here. Into. Okay, this is exactly what it says. Implementing so and so. This suffers the same restrictions and reasoning as implementing into. Yeah, the reason for that is because they're suggesting, well, they had a proper reason, but one of the other reasons is they're suggesting implementing from because there's a blanket implementation for into when you implement from. Now I'm trying to understand how try from and try into come into the picture. Where does it, okay, this trait must not fail. If the conversion can fail, then do so and so. Where does this mention? Okay, apparently try from and try into. Oh no, those are just links. Yeah, it's not mentioning either of them here. So that's kind of confusing. But no, if we go, how do we trace this back? Wait, let's read what Gemini is saying here. Um, Rust's standard library includes a blanket implementation that automatically provides try from for any type that already implements from. Because of this, the moment you write impl from so and so, Rust automatically creates impl try from where the error type is infallible, as in an error can never happen, an error that can never happen. When you try to manually write your own try from, the compiler sees two competing instructions for how to convert A into B, resulting in so and so. Why does the error mention into? Rust's trait system heavily relies on into being the directional inverse of from. The compiler's error message traces through these blanket relationships. From implies into, which ties into try from and try into, which is why into gets dragged into the error description. How to fix it? Scenario 1, the conversion can never fail. Okay. Scenario 2, the function, the inversion, the conversion. Oh my God. The conversion can't fail. So in that case, we use try from. Okay. You know what? I think I'm gonna end here. Um, yeah, I'll end here. I will continue digging into this because I'm really interested in finding out where the implementation for try from and try into are specified in the code in the standard library. I want to trace that back and see exactly, where it's saying what it's saying. Maybe I'm just not looking hard enough over here. Um, I need to eat something, dude. I need to eat something and then I'll feel better and then after that I'll continue with this. So that's going to be it for today's stream. I hope you guys have a nice day and I'll see you all next time. Peace.